Hi all, this is Vijay Patil, Assistant Professor, Department of Mechanical Engineering, Vivekananda College of Engineering Technology, Puttur. In this session, we are going to discuss some of the important things about the errors. What are the errors in the measurement? So, basically, what is the error? If you are going to measure any quantity in a mechanical components, definitely there will be errors in the measuring instruments, or it may be due to human reading negligence. Due to that one, the errors may occur, or it may be due to some external effects, or it may be due to internal disturbances that are produced in the measuring instrument. So that will cause the error. If any instrument there is a degree of uncertainty resulting from a measuring error, that means measurement error. That means, so there may be a parallax error, there may be a reading error, there may be a internal component which is malfunction that results in the error. So all these things contribute to the errors. Error is nothing but basically difference between indicated and actual value. Whatever the measurement we have done, that is indicated value, and whatever the measurement to be done, that is actual value. The difference between indicated value and actual value, that will give the errors. Basically, the errors are classified into two categories, that is static errors and instrument loading errors, or dynamic errors. So dynamic errors can be easily classified into controllable errors and random errors, which are under the control. The errors that can be controlled through the calibration, that can be classified as a controllable error, and random errors are due to mechanical vibrations, or it may be due to environmental disturbances. So that will contribute to the random errors. Let us see what is static error. How the static error is defined. It is the result from intrinsic imperfections or limitations in the hardware or apparatus compared to the ideal instrument. That means, over a long usage of time, the instrument is coming to the wear and tear stage. At that time, if it is not calibrated properly or maintained properly, if the instrument what we are going to use, if it is not serviced properly, that will lead to the internal disturbances while reading the measuring quantities. So that will lead to the static errors. And in static errors, there are basically different categories are there. One thing is reading error. That means, while reading the quantities, the quantity to be measured, like what is the angle between the two gear teeth, or it may be between the threads, or if you are going to measure the depth, or if you are going to measure the flank, if you are going to measure the angle between the two teeth of a gear, or screw threads. So at that time, you are going to use the optical microscopes, tool makers microscopes, or any projector lenses, in order to read the quantity being measured. So while reading, due to the human reading errors, the reading will occur. That means, there may be a parallax, or it may be interpolation, it may be optical resolution errors. So these will contribute to the reading errors. And second one is characteristic error. And characteristic error is nothing but it is a deviation of output of the measuring system under constant environmental conditions from theoretically predicted performance. See, due to the some environmental aspects, due to some moisture content that is present in the measuring instrument, if the instrument is not maintained properly, if it is exposed to the outer environment, and if the suitable environment is not given for a measuring instrument, so at that time there will be hysteresis, repeatability, or linearity errors that will come into picture. So about hysteresis, repeatability, and linearity errors, we have discussed in the previous session. So all these errors will come into picture when there is a environmental aspects are there, and this will contribute to the characteristic error. And let us see one more third error will be environmental error. That means, the result from the effect of surrounding temperature, pressure, humidity on a measuring system. That means, as I told, if the measuring instrument is exposed to the outer environment, if it is not stored in a certain predefined or a prescribed condition, so there may be a chance of errors due to the high temperature, or it may be due to variable pressures, or it may be due to humidity or moisture that will enter into the measuring system, that will lead to the malfunction of the measuring instrument, which will start giving the undesired readings. That means, the reading is going to vary from the actual value compared to the ideal value. So that will lead to the environmental error. That means, So all these errors are due to the maybe reading error, it may be due to static error, it may be due to environmental error. So all these errors are contributing to the undesired values. That means whatever the actual value we have to get, so that we are not going to get due to the different types of errors. Let us see second category of errors. That means, as I told, apart from the static error, there are also dynamic errors. Dynamic errors are caused by the time variations in the measurement and result from the inability of measuring system to respond faithfully. That means, so time variations in the measurement. Measurement means the quantity to be measured is nothing but measurement. Measurement may be angle, it may be distance, it may be time, it may be pressure, it may be volume, it may be density, it may be specific gravity, and whatever the quantity to be measured, that is nothing but basically it's called as a measurement, and that is going to vary from time to time. And measuring system is going to give the errors in the reading. That means it is not able to give inability of a measuring system to give the correct reading. That means it is not responding properly with respect to the time. That is nothing but dynamic errors. So dynamic errors usually the limited by inertia, damping, friction, or other physical constraints, or sensing or reduced display system. That means, so in a measuring system there will be a mechanical actuation systems, there will be a sensor unit will be there will be a control unit will be there, and there will be a PLC integrated control systems, PID control systems will be there. If any malfunction in the unit, it may be electrical or mechanical component, so that is going to give the incorrect readings. This will contribute to the dynamic errors. So usually if any mechanical malfunction is there in the mechanical unit, that means, so due to that one there will be a damping, and it may give the incorrect readings due to the friction between the two elements, due to the wear and tear, and due to some controller malfunctions that results in the incorrect readings. So all these are going to contribute to the dynamic errors. Again, one more type of error is nothing but systematic or a controllable error. Systematic error is just experimental mistakes. Whatever we are going to conduct the experiments on a particular set of projects on a measuring system. So due to some experimental mistakes or incorrect methods, so we are going to get the incorrect errors. One example you can take, if you are going to conduct the experiments on a science center, if you are going to build the slip gauge dimension of a inappropriate thing, so that will lead to the undesired angle. So that means there is a mistake in the angle to be measured. So this is a systematic error. And one more thing, if you are going to measure the screw thickness or a screw angle through the tool maker's microscope, so if you are placing the crisscross linings on a inappropriate teeth of a screw, or it may be gear teeth, so that will lead to the undesired flank angle, undesired module, undesired thickness, and undesired depth of a particular screw or a particular gear teeth to be measured. So this will lead to the experimental methods what we are going to follow. So actual method to be followed, if it is varying from the predefined method, so then it will lead to the systematic error. And these can be determined and reduced if attempts are made to analyze them. And we can, if you are going to analyze the whatever wrong things we have done, we can correct them, and you can get the correct readings. And next thing, these controllable errors are also caused by the ambient conditions and stylus pressures. Stylus pressure means if you take a hardness testing machine, wicker hardness or a brindle hardness testing, there will be indentation and there will be a stylus. If it is going to impinge on a metal to be measured, so that stylus pressure, whatever the pressure applied on that particular mechanism, so if any error is there in that mechanism, that will lead to the stylus pressure. So if a stylus pressure is going to vary, that will lead to the inappropriate results. And if you take a fluid measuring instruments, if any pressure variations are there in a manometer or in a venturometer or in a pitot tube, in RFI's meter, so if you take a impact jet on a machine instrument, if any stylus pressure is going to vary, so that will lead to the inappropriate readings. And avoidable errors. So avoidable errors, as I told, these are coming in the reading errors. So while we are going to read the results, so there will be a parallax effect, there will be a magnification misalignments. So if you correct them, these errors can be controlled. That's why these are called as a controllable errors. Whatever the things are which are under our control, so that can be calibrated, so that can be maintained properly in order to get the correct readings. And incorrect theory, that means presence of effects not taken into account. That means if any external disturbance or environmental disturbances, if they are not taken into consideration, so there will be small errors that can be neglected in case of some measurements, or in case of some measurements that has to be taken into consideration. Random errors are nothing but so these are the errors, any small variations in the position of a setting standard or workpiece, so that will lead to the random errors. A slight displacement of lever joints or measuring joints in the measuring instruments. As I told, a measuring instrument is consisting of several mechanisms. There will be joints, there will be links, so that will going to give the correct reading. So any small variations in the position of setting the mechanism or a standard workpiece, in misalignment between the two links of a mechanism, that will lead to the random errors, and that will lead to the inappropriate results. And transient fluctuation in the friction in the measuring instrument. That means in case of some measuring instrument, there will be a frictional material should be there. So if any fluctuation is there in a measuring instrument, that will lead to the transient fluctuation. Transient means the readings what you are going to get, so that is going to vary with respect to the time. So there will be a huge fluctuation that will be magnified if the measuring instrument is not calibrated properly. And operator errors in the reading scale pointer type of displays. That means whatever the operator scale is there, it may be needle type, it may be a digital one, it may be a conventional type of measuring instrument. That means there will be usually all the instrument what you can see in the laboratories and all, there will be a dial indicator. Dial indicator consisting of a measuring engraved scales will be there, and there will be needles, and through the needles we are going to measure the readings. That means there will be pointers or needles, and they are going to show the readings on an engraved scale. And we know what is the least count of that particular measuring dial indicator, measuring instrument. Using that one we can measure the readings. If any errors in the measuring pointer or measuring display units, that will lead to the random errors. And apart from that, one more thing, these are coming under the external disturbances. Due to noise present in the instrument, that will lead to the errors. And response time, delay in the response time, that will give rise to the errors. Response time means how fast is the instrument. That means in a lower period it should give the accurate results. So that is nothing but a response time of a particular instrument. This is also one of the desirable characteristics of the instrument. So the ideal instrument should have a high response time. That means within a low specific time it should give the correct reading, and it should be accurate. It should be avoided from the external disturbances, and it should be having the high sensitivity. And these are the some important characteristics of a measuring instrument. So in that, response time is also very important. And design limitation, if any error in the designing of a particular instrument, that will lead to the error. The design is related to misalignment of the mechanism, or a limited quantity being measured. That means if the measuring instrument is designed for only low limit, so then it is of no use. And the particular design of an instrument should be made in such a way that by keeping the quantity being measured under different conditions, different atmospheric conditions, that has to be taken care while designing a particular measuring instrument. And deterioration of a measuring system, that means due to wear and tear or aging or wear and tear drift. That means over a long usage of time, the instrument should be maintained properly or calibrated properly in order to get the correct results. Drift means there is a variation from a quantity being measured from time to time. That means the measuring instrument should give the correct reading over a repeated times. So if it is not going to give the correct result over repeated times, that means there is a drifting errors. And aging means there is a long usage of time. There may be wear and tear of the instrument. That is nothing but aging. That means the instrument has reached its threshold value, and due to wear and tear of the parts in the measuring instrument, this will give the errors. And environmental effects, change in our working conditions. If the instrument is maintained under environmental aspects, if it is exposed to the high temperature, if it is under the high humidity conditions or moisture conditions, then there is a environmental aspects come into picture, and that instrument is not going to work properly. And these moisture or high temperature conditions to be avoided, and instruments to be kept in a desired conditions or prescribed conditions. And one more thing, human errors are due to recording type or reading type or the methods what you are going to follow to measure the particular quantity of mechanical components. So that will lead to the human errors. And one more thing, uh, in order to avoid these errors, we have to strictly follow the pre-described methods or rules to measure the quantity being done. And we have to avoid the environmental errors, and we have to avoid the disturbances and noises and vibrations. And we have to calibrate the instrument time to time. We have to service them, and we have to maintain them properly in order to get the correct reading. By that we can avoid the random errors, static errors, and environmental errors and human errors properly. And before going to the transducers, different type of transducers, so let us see what is a general measurement system. Usually the measuring system will be consisting of three stages. In general, any measuring instrument if you take, that will be consisting of three stages. That is, one is detector, transducing or a sensor stage. That means whatever the input signal or input quantity being sensed, that is nothing but a detect stage. And there will be various type of transducers will be there, and there will be sensors will be there in the detector stage. Second one is a intermediate modifying stage or signal conditioning stage. Modifying stage, that means whatever the input quantity is taken by a measuring instrument, that has to be processed properly. That is nothing but signal conditioning stage or a modifying stage, that will be done by some controllers, some actuating units, or some mechanisms in a measuring instrument. And the third one is a readout stage or a terminating stage. Whatever the output to be measured, that is nothing but the readout stage. That will be indicated by some digital display or some mechanical pointers or dial indicators. These will be the readout stage. These conditions will be there in all measuring instruments. Let us see this figure. It is indicating generalized measuring system. As I told, there will be three stages. One is the detector stage, and through this one we can going to input the quantity being measured, and that is transferred to the modifying stage. That means this is a second stage. And here the signal is processed, or input quantity is processed. Finally we are going to get the output. That is third stage is the readout stage. In a readout stage, we can read the results through the pointer, or through the some digital indicators, or through some controllers. We are going to measure the measuring unit, measuring quantity to be done. That is nothing but this is the generalized measurement system of three stages. That means detector stage, intermediate modifying stage, and readout stage. And in a intermediate stage, what is going to happen? Then what is the whatever the input signal we are going to give to the instrument, that is processed properly. So how it is processed? Through some controller units, PID controller, proportional controller, integrated controllers, and fuzzy logic systems will be there. The purpose is in this stage to modify the transduced information so that it should be acceptable. That means that has to be suitably accepted by readout stage, and that it should be indicated properly to the user. And important function is to increase the amplitude or power of signal. That means whenever there is amplification is required, that has to be amplified, or if it is of a high bandwidth, and if it is to be lowered, that at that time amplifiers come into picture. The role of amplifiers is to increase the bandwidth or decrease the bandwidth of signal. And some examples, transducer or modifying stages. In mechanical, the gears, cranks, links, or cams are going to modify the inputs quantity through some mechanisms. And coming to the electrical amplifying systems, matching devices, filters, noise filters, vibrational filters. So all these are going to help in a transducer stage or a modifying stage. And coming to the optical transducers, like mirrors, optical filters, light filters, optical fibers. So these are going to help in a intermediate modifying stage. And the third stage is nothing but a readout stage. Readout stage is in general whatever the quantity being measured, that means whatever the measurand is there, that has to be read by a user properly. That has to be easily read by any worker or any user who is going to work on that particular instrument. Readouts, maybe some digital, it may be some recorders like a pantography, mechanical recording, or ink pen, or a chart type of light beam type of recording, or a digital printing. So all these are coming to the recorders. And digital means direct alphanumerical readout. And displacement, these are that means the dial indicators, or a moving pointers, a scale or index, some liquid column like manometers. If you take any fluid measurement to be done like a discharge, at that time we are going to use the manometers. We are going to use the RFIs meter, venture meters, pita tubes, notches and all. So while we are going to use the any fluid property, so at that time we are going to use the liquid columns. So all these are a displacement type of measuring instruments. And some may be digital one, or some may be recorders. So these all are going to help in a readout stage. That means the third stage of the general measurement system. This is a important some pressure gauge, that means a board-on tube. So in the figure you can see the various parts of a board-on tube. There will be a gear mechanism, pinion type of a gear mechanisms will be there. Some levers are there, gear levers are there. There is a pointer indicator, and adjustable link is there. And there is a stopper is there. Some board-on tube scales are there. And all these parts are going to help in measuring the pressure of a particular fluid. And this is some pressure measuring device, pressure gauge. You can see the range of this pressure gauge is 10 bars or 150 psi. And various lines are engraved on this dial indicator, through which we can measure the pressure gauge. So these pressure gauges are attached to the some fluid measuring devices. Through this one we can read out the proper properties of the quantity being measured, fluid quantity being measured. And coming to the transducer, what is the role of a transducer? Why the transducers are used, and what is the important role of a transducers? Basically, the transducer is a device that converts a signal in one form of energy to the other. That means if it is an electrical quantity, that may be converted into mechanical one. If the mechanical quantity is there, that can be converted into electrical one. So the one form of energy is converted into another form. So this is nothing but this is going to happen through the transducer. So basically it's a device that will convert one signal in one form of energy to the other form of energy. And transducers are widely classified into different categories, like a passive transducer, active transducer, primary transducer, and a secondary transducer. Let us see one by one. Primary transducers, passive transducers. Passive transducers component whose output energy is supplied entirely and almost entirely by its input signal. That means there is no extra power is supplied to the transducer. So whatever the signal we are going to input, that is nothing but a primary source of energy for it, and no other source of energy is supplied to it. The output and input signal may involve the energy of the same form, and there may be energy conversion from one to other. The best example is bonded wire strain gauge. The passive transducers, that means a bonded wire strain gauge used to measure the strain in the mechanical equipment. So any deformation is there in the component, that is measured by a bonded wire strain transducer, and that is going to pick up the whatever the deformation is there, and that is converted into equivalent electrical output, and we are going to measure the strains, micro strains in a digital output of the display. That can be possible through the bonded wire strain gauge. And active transducers, so these are having an auxiliary source of power, and which supply major part of the output power, and here some extra sources are to be given to get the outputs. And active transducers are self powered, and electrical amplifiers, piezoelectric transducers are acting as active transducers. And let us see the primary transducers are best examples are boron tubes or strain gauges. These are acting as a primary transducers. Transducer which sends measurement and converts them into another variables like displacement and strain, whose output forms the input of another transducer, is called a primary transducer. That means if any physical want to be measured, that is equivalently processed, and output is given in another form. So like displacement strains are measured in electrical forms, and if any strains is there in a mechanical equipment or a mechanical component, that will be measured in terms of microstrains in a electrical form. So that is nothing but a equivalent conversion. Primary transducers are going to help in a conversion of one quantity to another quantity. So examples are boron tube and strain gauges. And secondary transducer which converts the output of a first transducer into a electrical output, is called as a secondary transducer. And that means the first transducer into electrical output, like LVDT and all. LVDT is going to help in a force measurement, or it may be used to measure the displacement or pressure measurement. And this the force which is in a Newton, or a pressure in a Newton per meter square, and all these displacements in mm. So all these physical quantities are equivalently processed, and the measurement is being done in a electrical output, equivalent electrical output. So that is the role of a secondary transducer. And coming to the mechanical transducer, mechanical transducers are primarily used to convert the applied force into a displacement. And mechanical quantities basically include force, pressure, flow rate of any fluid, displacement, and temperature. And they may be subjected to direct tension, compression, and bending and torsion. Obviously, if the mechanical transducer is going to help in uh, applied force or displacement into another form, there will be some mechanisms or some systems will be there inside measuring transducers. So that are under sometimes they will be under some tension, there will be some compression, and there may be some bending or torsion between the two mechanism or two elements. Best example for a mechanical transducer is spiral springs, torsion bars, probing rings, board-on tubes, diaphragms, and bellows. And spiral springs are going to use in suspension systems, and torsional bars. If any torsional element is there, in order to measure them, we are going to use the torsional bars. And probing rings, board-on tubes, diaphragms, bellows. These are going to help in fluid measuring systems, some fluid pressure measurements. So all these are coming under the mechanical transducers. So coming to the diaphragms, elastic diaphragms are used as a primary pressure transducers in many dynamic pressure measuring instruments. And these diaphragms may be flat or corrugated. That means Flat diaphragm, you can see the figure number 1. In a flat diaphragm, the diaphragm element is going to under some bending conditions whenever there is a applied pressure applied on opening 1 and 2. If you see the pressure P1 and P2, and there is a element flat diaphragm element will be there. Whenever the pressure is applied, that is filament is going to bend, and through that one the measurement is done. And corrugated means the filament or a diaphragm filament is there. It is not in a straight manner, it is crisscross manner, it is a folded manner. Whenever there is a pressure applied, through that one, through the elongation of that particular diaphragm filament, we are going to measure the quantity being measured. A diaphragm is a thin, flat, circular shaped fixed around its circumference. Whenever there is a pressure difference between P1 to P2 occurs, at that time it will deflect. Through that deflection, the displacement transducer is going to act, and it's going to give the suitable strain that is sensed by a suitable sensing strain cases. And alternative form of diaphragm to obtain the larger deflections is the metallic capsule or a pressure capsule. And the two corrugated diaphragms are joined back to back, two edges, and these are acting as capsules, metallic capsules. And the pressure P2 is applied to the inside of the capsule, which is surrounded by the pressure P1. If you see this figure, there will be corrugated capsules. Two corrugated capsules are joined back to back, and two pressures P1 and P2 are applied. So through the elongation of that particular diaphragm, we are going to get the pressure. We are going to measure the pressure of the particular fluid. Coming to the electrical transducers are usually secondary transducer that will convert the displacement of a primary sensor into an electrical one. That means whatever the displacement or any elongation is there, that will be suitably processed, and it will be converted into electrical current or resistance or voltage. That means mechanical property is converted into electrical property. And best example for electrical transducer is the thermocouple, and current will flow in a continuous circuit of two metals if two junctions are at different temperatures. So basically the thermocouples are used to sense the thermal conductivity, and they are going to measure thermal conductivity of a particular metals like bronze, copper, and mild steel. So thermocouples are going to measure the thermal conductivity, thermal property of a particular metallic elements. Why the electrical transducers are of highest use? Why they are used widely? One thing is because of small size, and they are compact, and frictional and inertial effects are reduced. There will not be any frictional elements, and there is no much inertial effects are there. And remote recording and control is possible, and amplification and reduction of signals may be easily obtained. That means a remote recording or a control. That means since they are electrical one, they can be programmed properly, and they are closed control. They are having the closed control system. We can easily control them without any assistance of a operator who is going to continuously touch with the instrument. We can remotely control the instruments, and amplification and reduction of signals may be easily obtained, and less power consumption. A signal output may be easily processed and transparent. These are the important advantages. So that's why electrical transducers are of highest usage in the market. And resistive transducers, resistance of an electrical conductor varies according to the relations R equal to rho L divided by A. That means resistance transducers are play a very important role whenever there is a electrical resistance to be applied on a particular signal that is going to process. At that time we are going to use the resistance transducers. So the relation is R is the resistance in ohms, rho is the resistivity of a particular material, L is the length of a conductor, and A is the cross section of a conductor. So R equal to rho L by A. This relation will give the relation between the resistance and the resistivity of a material with respect to the length and area. And capacitive transducer is nothing but capacitance or a capacitor is basic role of capacitor is to store the charges. The principle of operation of capacitive transducer is based on a capacitance of a capacitor. If any variations in the capacitance are used to produce a measurement of many mechanical physical phenomenon like dynamic pressure measurement is there, if any displacement force measurement is there, and any humidity measurement is there, if any measurement of liquid or gas levels is to be done at that time, so we are going to use the capacitance transducer. Capacitance is a function of effective area of conductors, separation between them, and the dielectric strength of a material in separation. That means C equal to 0.088 K into n minus 1 divided by D. That is measured in picofarads. So the related terms is indicated here. K equal to dielectric constant. For air, the K is equal to 1, and A is the area of one side of one plate, and the centimeter square or meter square, and is the number of plates. D is the separation of two plate surfaces in centimeter. That means capacitive transducers are going to store the physical quantity to be done, and that is suitably processed properly through the capacitance transducer, and finally we are going to get the correct reading or output in a suitable manner or a readable manner. And in capacitive transducer there is different types are there. Changing dielectric constant, that means the dielectric two electric fields are there between the two capacitive transducer elements, and this dielectric variation will be done between the two plates. The capacitance between the central electrode and the surrounding hollow tubes varies, changing dielectric constant brought about by changing the liquid levels, and thus capacitance between the electrodes is a direct indication of a liquid level. If you see the figure here, directly you can go through this figure. There are some capacitance materials are there. Two capacitance materials provided at the opening. They are immersed in a one fluid, and they are surrounded by a hollow tube. There is a central electrode is there. So if you are going to measure the fluid level or any fluid pressure is there, so through the central electrode you are going to get the output. Through the opening, the fluid is going to fill the hollow tubes, and through the central electrode we are going to get the capacitance. That means two hollow tubes are going to act as capacitance elements. So between them dielectric medium is going to connect them, and we are going to get the output through the capacitance electrode. And these are some aspects of a capacitive transducers, and this is a capacitive torque meter. That means two elements are there, like one is internal member with teeth and a sleeve member with hollow teeth. In between these mating two components there is a air gap. Through the air gap, so the torque meter is going to work. That means whatever the air pressure is going to happen between two elements due to the capacitive type, and these torque meter is going to show the readings. And this is a pressure pickup type of transducer. That means capacitive type. There is a one capacitance element is there, and there is one diaphragm. Whenever there is a distance, it is going to vary through the distance between the element and some diaphragm. If the element is going to act some pressure or a force, then diaphragm is going to change its shape. So that means whatever the deform is going to occur in a diaphragm, that is sensed by capacitance, and that is captured, and readings will be given. The suitable pressure is going to measured by them. And what are the advantages of capacitive transducers? It produces an accurate frequency response to both static and dynamic measurements. High resolutions can be obtained. Loading effects are minimum and high sensitive. The capacitive transducers are of highest sensitive, and one of the important desirable property of measuring transducer. And the loading effects, whatever the loading effects are that can be minimized. High resolutions can be obtained, and both static and dynamic errors are removed, and The dynamic measurements can be done easily and static measurements can be done easily with accurate frequency, and high response is there through the capacitive transducer. These are some advantages of capacitive transducers. And disadvantages, uh, due to the increase or decrease in the temperature or to the higher level, there will be change in the accuracy of a device. Accuracy will vary from temperature, high temperature, and as lead is lengthy, it can cause the errors in the distortion in the signal. That means, as the lead is lengthy, that means whatever the measuring type is there, capacitive transducer, there will be a high capacitance element will be there, diaphragms will be there, some actuator element will be there. Due to the lengthy, so it can cause in the errors due to distortion of the signals, capacitance of signal. That means whatever the electrical part is there, that is connected to the mechanical part, it's of a high length. Due to that one, there is a amplification errors will be there. Due to that one, signal variations or distortions will be there, that will lead to the some errors. The instrument circuitry used with transducers are complex. That means whatever the circuit is there or a circuitry is there, that is of a complex thing, and all the systems should be used in a closed manner, or closed control should be used, closed controlled circuit should be designed. So this will lead to the complexity in the instrument. These are the some advantages of capacitive transducers. And so these are the things we have to study some important aspects of errors, different types of errors, and how to avoid the errors. What are the different effects caused by errors in the measuring instrument, and what is the role of a transducer in a measuring instrument? What are the different types of transducers are there? Mechanical, electrical, and we have discussed some mechanical transducers, and we have discussed some electrical transducers, and advantages and disadvantages of those transducers we have studied. And these are the things going to help in measuring instruments. And let us see some of the important aspects in next session. And thank you, goodbye, and have a nice day.